I did. Hey, welcome to You Never Talked About This, Mr. S. And if you're here, it's because you probably don't remember that I did talk about it. Today, density. Now you've all become pretty good at remembering that density has something to do with objects sinking and floating in water. And you're not wrong. Density has to do with buoyancy. But remember that buoyancy is the ability of an object to float. Density, however, is so much more than what buoyancy is. Density is actually a measurement of how tightly packed the particles inside an object are. We all remember that particles in a solid are tightly packed together, while particles in a liquid are sliding one on top of the other, and particles in a gas are flying all about. However, not all solids have their particles packed in the same way, not all liquids have their particles sliding in the same way, and not all gases have their particles flying about in the same way. For example, these two objects are spherical in shape. This one is a bocce ball made out of a hard compressed plastic, while this one is a foam ball made out of foam. Now, they're both solids, so we know that the particles are packed together. However, the particles in this bocce ball are packed much tighter than the particles in this foam ball. That's what makes this ball sink in water and this ball float in water. Now, this is a cool example that will help you visualize what density really is. Let's imagine that this is the foam ball. Now, these marshmallows that I have in my hand, and some of them are inside the sphere, are the particles. So I'm going to start putting more particles inside the sphere, not on the floor, inside the sphere. Now you can see the way the particles are arranged inside the foam ball. I mean, we know that they're not all in the bottom, but they have a specific configuration. But the thing is that they still have space in between them because they're not as tightly packed as they are in the bocce ball. On the opposite hand, you have the bocce ball. Now it's filled with particles, and particles are much tightly packed one against the other, and that makes this object more dense than this. Now we call density relative density, and when we call it relative density, it's because we're comparing it with the density of something else. For example, the density of this bocce ball is more compared to the density of water. That means that this bocce ball will sink in water, while this foam ball, the density is less than the density of water, so that means that the ball will float in water. What's really happening is that the particles in this bocce ball, which are tightly packed together, they're more tightly packed than the particles in water. And so when the particles in water feel that the bocce ball is coming, they can't hold it because their particles are not tightly packed, and so the bocce ball sinks. However, these particles are more loose one against the other, and when it comes to the surface of the water, the particles in the water say, oh, we can hold that. And so it makes this object buoyant and this object not buoyant. Now, we've discussed density here using examples of solids in liquids, but remember, the same rules apply for liquids in liquids, or even gases in gases for that matter. I'm sure you remember when we were creating mixtures in the lab and we mixed oil in water, we saw that oil floats in water. Well, the reason why oil is buoyant in water is because the particles in the oil are less tightly packed than the particles in the water. So the particles in the water can hold the oil up, and so we say that oil has less density than water. I hope that this quick explanation kind of reminded you what density really is, and please remember that density, as with everything in science, has a connection to math. There's a specific mathematical way of finding a numerical value of density for the objects, and for that you would need to find the mass of the object and the volume of the object. Once you know the mass of the object, which you know how to measure using a triple beam balance or whichever other instrument, and you find the volume of an object using, for example, water displacement method, or a ruler if it's a specific shapely object, then you can divide those to get the density. But that's later on. Anyway, I hope that density now is clear in your mind, and if not, go back to your ISN, review the things that we did in class, come back, watch this video, or go to YouTube. There's a ton of videos that explain you, probably better than I did, what density really is and how to measure it. Till the next time.